1. It's just 0. So we cannot we don't need write 0 here because 0 is 0. Okay, 0. We we don't need show. Okay, this is derivative, but we can improve doing this math. So x to the power of 1, but to the power of 1 is only, you don't need show again. So this is the derivative, okay? Just like that. This is the
Yeah.
function, this is derivative, but you first need to do the math, do the multiplying first, okay? But the multiplying is easy to you. You is a very smart guy, very smart guy. So at this moment, I will uh, speak to you, do some math here. You need to do this math to me. This is very easy to, okay? To the power of 3, okay? Do you know the rules? You have my example, so I will send to you this, and you can use this like example. I will send to you in your WhatsApp, okay? Man, I really need to go to the bathroom. In the when I come back, you say to me the answer, okay?
Okay.
Okay, it's just a minute. Thanks, man. Yeah, hey man, did you do the derivative?
Um, uh, I didn't really understand. So with the this one, it'll be bracket 2x power of 2x squared plus 3 and then bracket and then
Yeah,
another bracket 2x power of 2 three times.
3 times, yeah. The multiply is 3 times here because the exponential, all right?
Yeah.
Yeah,
So it'll be 8x power of 6
okay, x 8, x power of 6,
plus 36x power of 4 and plus 54x power of 2 54
54, okay,
plus 27.
87. You don't have some term with only the x? I suppose not, because we have the 2 here. So, perfect. This is the multiplication. Perfect. Now you need to do the derivative. Okay. Do you have the rule? Do you have the rule? You have the rule, sorry. You have the
Yeah.
rule. So you just need apply the rule here. When you do this, tell me, okay? Just remember the rule. The rule is easy. If you have a function, k x to the power of n, the derivative is k n x to the power of n minus 1.
So for example, 8 x power of 6 will be 8 times 6 x power of 6 minus 1.
Perfect. Right.
And do I also get the derivative of number 27?
The derivative of 27 and 28 and 132 is the same thing ever, 0. If the
Okay.
number, if it is the constant, the derivative is 0, okay?
So the answer of 8x power of 6, the derivative of that is 48 x power of 5.
Yeah, 48 times x to the power of 5. The first term is this, okay? So when you finish it, you can take a photo and send me, okay?
Yeah. I sent you my answer.
Okay. Just a second. When you send me photos, um, turn the photos right, okay? Because
Okay.
the photo is here to me. It's
Yeah.
bad. This is bad. But okay, no problem. So you just um, drop out the number and you do the multiplication. Perfect. Perfect. Muy bien. So I will do a new example and you will do another one. For example, if you have this this situation here, fx equals, for example, square root 3, I don't know, 2x, for example. Here we have this problem. This problem of um, square root. Square root is is boring. It's very boring. But we can do a simple math first. For example, we know the square root, this root, is a exponential, but it's a fraction. It's a fraction exponential. This is equal to the 1 over 3, right? It's the same thing.
Yeah.
It's the same thing. This and this is the same thing. Okay? Okay, this is very easy. It's just a exponential rule. The rule is you have a and 3, a and m, it is equal n over m. But you can change a little more. For example, you can do this. The exponential goes in the two terms, okay? And now we can do the derivative. The derivative is the polynomial rule again. So we have 2 to the power of 1 over 3. Now we do the derivative. 1 over 3 drop out. X to the power of 1 over 3 minus 1. So what we can do now? We can, for example, multiply these terms to write something more beautiful. For example, 2 1 over 3 to the power of 3x. Here we have the situation of a fraction situation. But I know that you know that 1 is 1, the number 1 is the same thing of 3 over 3, okay? So we have this situation here, very easy, very cool, and now you have another count to do to me, okay? You need to do this derivative, okay? It's the same
Okay.
rules, the same thing, fractions and stuff, okay? Just do. If you have some problem, just tell me, okay? Do the derivative.
I sent you my answers.
Okay, just a second. Oh, the photo is right. Let me see the math. So you change the thing. Just a second. Okay. We have a lot of things happen now. Just a second. I really need to, if you do the first math right. 3. Okay, 3, because the multiply of the exponential things. Go here and here. 2 times 3 is 6. Okay, amazing. So we have the under 4 here, but here we have 6 too. Okay, because the number have only this 3 and this 4. Okay, man, amazing. The first math is right. Okay. Let me see the derivative now. Just a second. So you only do the derivative of the letter. So your letter drop out the number. But what's the number of the letter? 6 times 6 is 36 over the 4. So 36 divided by 4 is 9. So drop out 9 here, and 9 minus 1 here. Okay, amazing. Is right. But the ultimate, the last thing you wrong. You cannot do this. You cannot only multiply 9 to 27. You cannot do this. Because why? No? Because why? Because the 27 have a exponential. Okay, you have this exponential, so you cannot do so free this multiplication.
Yeah.
Your math is right until here. Until here, where I am passing my hand, my little white hand. Here not. Okay, here is wrong. Very, very wrong. But okay, this is enough to me in this situation. Mm, so so let's go. Let's do one more because we have only 10 minutes. It's more interesting with training our derivatives. Let's do some strange derivatives. For example, if you have this situation, this strange situation here, for example, you have, I don't know, pi over 3 x to the power of pi to the power of pi square root pi. Very strange number. And if you have, I don't know, 10a, another letter A. And if you have this, a lot of pi's in this math, in this count here. Let's do the derivatives. We can do the derivatives term by term. In other words, we can do this here, and here, and here. Where you have sums or negatives, I will put a negative here. We always can do this, okay? Very good. So let's do the first. I will do I will do each part separately, part by part, step by step, okay? In the finish, uh, I will put together, okay? So here, what's the derivative? The constant stay here. This number drop out, multiplying, and I will take off this parenthesis. And here we have the same exponential minus 1. This is the derivative of this term. Very easy, but the numbers is strange. But the situation is this. It's the same thing ever. Regardless the numbers, regardless the appear of the numbers. Pi is a number, okay? So let's do this derivative. Our derivative is in x because the variation is in x, okay? So if you have another letter, like letter A here, we can look this and we know this is a constant, okay? This is a constant because 10 is a constant and A is a constant in this situation. Because in this situation, the only thing is not a constant is x, only the x. So the derivative here is 0, okay? Any problem? Do you have any problem?
No. So any other numbers other than x will be constant.
Yeah, just like that. And here we have this, again, the situation when you need multiply first. Okay, so let's multiply first here. We do the distributive property. So you have x squared plus pi x. Now you need derivate this, and the derivative of this is 2x plus pi. Okay? So we have the
Yeah.
parts. The parts you just need put together these parts. So I will erase this and copy this. I think is not. I don't have space to put here, but no problem. I will erase this because this is 0. The derivative is 0, so we have space now. And the derivation of this term is the last one. This. But you need, remember, I changed the sign, minus. We have minus here. So the minus need be in front of the two terms. All the terms you derivate, okay? You cannot forget this. This is very important because the sign is for all numbers, okay? So this is the derivation, very easy. We don't have much time, so I will do some exercise to you train your derivatives in our next class. We have class, just a second. We have class Thursday, 4 p.m. You show to me these exercises. I will send to you today, okay?
Okay.
Okay, amazing class. You are very cool and very calm. This is cool. I see you Thursday. Okay? I see you Thursday. I will see you Thursday. Bye bye.
See you.